Number 1 says that Kieran plans to save $200 per year. Bank A would pay 6% interest and Bank B would pay 4% interest, both compounded annually or once a year. How many years will it take to save $10,000 if he uses each of the banks? So you learned a formula for this. And that formula is that the sum equals the annuity or the amount he's putting in each year times 1 minus the growth rate to the nth power, which is how many years this is happening for, divided by just 1 minus the growth rate. So a couple of things to recognize in here is specifically with this rate. So here's the interest rate, but this is the growth rate. So he's getting an extra 6% here, but he's also getting back his initial $200. So we're figuring out 6% of the 200 plus giving him his $200 back. So he's not only getting the extra 6%, he's also getting 100% of what he put in. So this is giving him a growth rate of 106%, or as a decimal, that's the decimal 1.06. So this is the growth rate for Bank A. And then Bank B at a 4% interest rate would mean that he's getting back 104% of his $200. And as a decimal, that's going to be 1.04 when we plug it in. So just be careful of that. So in both of these cases, we're trying to figure out when it will equal 10,000. So for Bank A, we're saying 10,000 is equal to 200 times 1 minus that growth rate of 1.06. And then to the n, which is what we're looking for, is how many years this will take. And then over 1 minus the 1.06. And then for Bank B, we're doing nearly the same thing, except for this rate will change. We still want to figure out when they're going to get $10,000. And he's putting $200 into this account. And now this time is looking at a growth factor of 1.04 or 104% of his investment. So in this case, you're going to be looking at, I would just look in your calculator. So you can type this into your graphing calculator. We are just going to not type in the 10,000. We're going to look for that in the table. So I'm going to type in, and I'm going to put parentheses around the top. So 1 minus 1.06, and then to the n power. So this will just say x in your calculator. It's just a variable. And then close the parentheses. So that's the top, divided by, and then put a parenthesis around to get the bottom. So 1 minus 1.06 on the bottom there. Close that parenthesis. And then you're going to want to go into the table so that we can just see plugging in a bunch of different values. So we'll go to second table. So -2 would be he's investing for -2 years. That doesn't make sense. And, oh, whoops, I forgot the 200. So let's put the 200 in here. I forgot the 200. So make sure you get the $200 in front of that and then type in the rest. So then go into the table and take a look. So after the first year, he's got $100, or he's got his $200. Okay, so let's go and see where this gets to 10,000. So we're at 3,000, 4,000, 7, 8, 9. Okay, so here's where it hits 10,000 is somewhere between year 23 and 24. So it's going to take him till the 24th year to have $10,000. So at the end of 24 years. Okay. For Bank A. So then for Bank B, now we'll just go in and change the rate. So now everything else stayed the same. He's putting $200 in, but now this time it's a 4% interest. So we're going to change it to 1.04 on the top and the bottom. and then we'll go back in and push second graph so we can get into that table and see when this one will reach 10,000. And it makes sense that it's going to take longer because we're getting less money each year. We're getting 4% instead of 6%. So here it happens after year 29. So in year 29, we'll get that $10,000. Number 2, find the sum of the first 20 terms of each sequence. So again, we're going to be using that formula. So S equals the A, or the initial value, and then 1 minus the rate to the n over 1 minus the rate. And so we need to figure out what the rate is here so we can plug it in. So what are we multiplying by each time? And so this one's kind of easy to see because it's 1 times what? Well, 1 times 2/3. If it's not as easy to see, remember you can take the second term and divide it by the first term to figure it out. But so our R here is 2/3, our A is 1, so that initial term. So our sum is going to equal 1 times 1 minus R, 1 minus the rate, which in this case is 2/3. And then to the 20th power, because we're plugging in 20, this is our n. So 2/3 to the 20th, and then divided by 1 minus 2/3. And so you'll want to type this into your calculator. So let me just show you how to do that. So on your main screen, okay, and you can type in 1 if you want to. It's not going to matter in this case because it's a 1. Then I would put in 2 parentheses, okay? So 1 for the top, okay? So here's for the top, 1 minus, and then you're going to want to put a parenthesis here for 2/3. And then you want that 2/3 to go to the 20th power. Then we'll close the parenthesis. So this is the top. And then we want to divide by the bottom. So we'll put a parenthesis around 1 minus 2/3. And now you don't need a parenthesis around 2/3 this time since you're not bringing it to a power. I only did it because I needed to bring it to an exponent. So then you can close off the bottom parenthesis and then close out your overall parenthesis and then push enter. So this is your sum, 2.999. And you could do that in steps if you wanted to, if you don't want to try and type the whole thing into your calculator. So you could do 2/3, hit enter, bring that to the 20th power. Okay, so that's this. Then do 1 minus. Now this little thing right here says answer. So you could hit second and then your negative sign. So now you're doing 1 minus this. And then you're going to divide that by this whole bottom. So I would put a parenthesis there to get 1 minus 2/3. And then you'd be taking it times 1, which won't change it in this case, but we got to that same answer. So make sure whatever calculator you're using and however you do it, that you're getting 2.999. All right, then the next one, so we want to figure out what are we multiplying by here, okay, to go from 3 to 6 to 6/3. Okay, so you can think of this as a fraction. And what are you multiplying the top by here? We're multiplying by 2. What are we multiplying the bottom by? 3. And then see if that keeps happening. 6 times 2 is 12. 3 times 3 is 9. 12 times 2 is 24. 9 times 3 is 27. So here's your rate. And your initial term is a 3. So we're going to get 3 times this whole thing, 1 minus 2/3, again to the 20th, because we're doing 20 terms, over 1 minus 2/3. So then we'll go and type that into our calculator. So I'm just going to do it all in one step. So I'm going to put 2 parentheses here. So 3 times 1 minus, and then a parenthesis around the 2/3 so I can bring it to the 20th power. Then close that top parenthesis, divided by a parenthesis around the bottom, 1 minus 2/3. And then I'll close off both parentheses and hit enter, and we get 8.997. And then the last one, so what are we multiplying by here? So it's really, it looks like dividing by 2, which remember is the same as multiplying by 1/2. So our rate is 1/2, and our initial term is 4. So then we're going to get 4, and then 1 minus 1/2 to the 20th over 1 minus 1/2. Okay, so then when you type this one in, now before 2/3 as a decimal is a repeating decimal, so I had to leave it as a fraction, or I left it as a fraction. In this one, 1/2 is just the decimal 0.5. So for this one, if you want, when you type it in, for the top, you can just do 1 minus 0.5 to the 20th, and you don't need a parentheses around that decimal if you don't want to. If you type it in as 1/2, the fraction, you would, but as 0.5, you don't. And then divided by 1 minus 0.5. And then that'll give you the decimal of 7.999. All right, number 3, Diego wonders how much money he could save over 25 years if he puts $150 into an account with 4% interest per year compounded annually. He calculates the following, but thinks he must have done something wrong since it's such a small number. So the total amount that he ended up with, if he's putting in $150 a month for 25 years, is $156. So that doesn't make sense because he's putting $150 into the account every single year. So he should have way more than that. So what did he forget in his calculation, and what should his total be? So remember, when we're talking about these interest rates, right, you get this 4%, but it's an extra 4%. So you get the 4% plus you get back 100% of your investment, of your $150. So for this one, the rate, or the growth rate, is 104%, which is 1.04, not just 0.04, which is what Diego did. So he should have had 150 times 1 minus 1.04 to the 25th power divided by 1 minus 1.04. Okay, not just 1 minus 0.4. So this bottom, when you do 1 minus 1.04, would be negative 0.04. So then we can just type that in, and you don't have to calculate that if you don't want to. You can type it in your calculator. So if you do 150 times 1 minus 1.04 to the 25th power, and then close that for the top, then divided by, and then get the bottom in there of, and you can, like I said, do 1 minus 1.04 instead of actually calculating that ahead of time if you want to. And then push enter. So he should have had $6,246.87. So much more reasonable when you're putting $150 a year for 25 years to have that much. Number 4, which one of these equations is equivalent to this when x isn't equal -4? So remember, if x is -4, it makes division by 0. So we just clarify that we're not going to be plugging in -4. So remember that this is a proportion. So one of the things we can do is cross multiply. So we can do 8 times 4 plus x, and then equals 1 times 3 plus 2x. So just 3 plus 2x. So here's one equivalent expression, which matches A. So that's the one we already found, and we only need 1. So that would be our answer. And so you can see on this one, they multiplied by the wrong things. They multiplied by the top here. Here they did some subtraction. And here they, I don't know, flipped over the 8 with the 4x, but definitely not any of these. So that cross multiplication gives us A. Number 5, A cubed plus B cubed equals this. Is that an identity? Explain or show your reasoning. So remember, an identity means that if you multiply this part out, okay, it will equal exactly the other side. So let's multiply this out and see if it equals A cubed plus B cubed. If it does, then it's an identity. So we're doing a binomial times a trinomial. So let's get a 2x3 box drawn here. And we're doing A plus B times A squared minus AB plus B squared. So A squared times A is A cubed. A squared times B is just A squared B. A times negative AB, so we've got an A times an A, which is an A squared, and then we've also got that B. So negative A squared B. Negative AB times B, so we have the negative A, and then we have B times B, which is B squared. A times B squared, so we just literally have A times B squared. And then B squared times B is B cubed. So then we'll take a look at some like terms in here. So these two are like terms. So this is 1A squared B, and this is negative 1A squared B, so those equal 0. Negative AB squared and positive AB squared. So that's a negative 1AB squared and a 1AB squared. So those equal 0. And we're left with A cubed plus B cubed, which is exactly what this side said. So yes, it's an identity. Number 6 is this an identity. So same thing that we're going to be doing here. So this time we have a binomial times a quad. So when we write out our box, we're going to have 2 rows, and then we're going to have 4 columns. So we're going to be doing A plus B times A cubed minus A squared B minus AB squared, and then plus B cubed. So A times A cubed is A to the 4th. A cubed times B is just A cubed B. And I always write them in alphabetical order just to give myself some structure. So then negative A squared B times A. So we have negative, and now we have A cubed since we did A times A squared, and we still have that B. Negative A squared B times B. So our A part doesn't change. So negative A squared, and then B times B is B squared. Negative AB squared times A is negative A squared B squared. And you could probably stop here because you can see that this isn't going to equal out to this. And you probably could have stopped here even because I guess you couldn't stop here because this is going to cancel out. But if you take a look here, you've got negative A squared B squared, and you got negative A squared B squared. That's negative 2A squared B squared. And we don't see a term like that in here. So it's not canceling out here. And so you could stop there and say not an identity. But if you wanted to keep going, we've got negative AB cubed for this one. And then here we'd have AB cubed. And here we would have B to the 4th. So this one is certainly going to cancel out negative AB cubed and positive AB cubed. But that middle term here didn't cancel out. So no, not an identity. Number 7, this formula sums the first n terms in a geometric sequence. So let's take a look. We've got a medicine is prescribed for a patient to take 700 milligrams every 12 hours for 5 days. So every 12 hours for 5 days means that you're going to take 10 doses. Okay, because there's 24 hours in a day, so you're taking 2 doses per 5 days. So after 12 hours, 4% of the medicine is still in the body. So how much of the medicine is in the body after the last dose? So this means that our rate is 0.04 because you only have 4% left after those 12 hours. So our original amount is 700, which is the dose. And then we're doing 1 minus the rate, which is 4%. And how many doses we're taking is 10, because again, 2 per day for 5 days. And then 1 minus the rate of 0.04. We would type this into our calculator, and you'd get about 729 milligrams.